Okay, we're looking at exercise 11C from the first year mechanics textbook. So question 2, we're given an expression for the displacement, and the displacement is in terms of time, and we're told that time is only ever between 0 and 4 seconds. So show the body returns to its starting position at t is 4. Right, so the displacement is given by 40 cubed minus t to the power of 4, and it's going to return to its starting position when that is 0. So although that's a quartic, it's actually very easy to factorise. So I'll just take t cubed out as a common factor. So I get two solutions, t is 0, t is 4. So it was a show that question, so I've just got to write a conclusion. So when t is 4, s is 0, therefore the body has returned to the start, into the start position. Okay. Right, so part B. So explain why S is always non-negative. Okay, so these ones can be quite tricky just to sort of figure out how you're supposed to tackle it. So the first thing I would think about, because we don't really want to have to sketch that, because if you've got a graphical calculator, you could do a sketch just to clarify what's going on, bearing in mind it's only between t is 0 and t is 4 that we're looking at. So you certainly could have a sketch and sort of justify it that way, but let's have a look at the actual function. So s is 4t cubed minus t to the power of 4. Now, it's quite hard to draw any conclusions from that, because so if t is always between 0 and 4, then 4t cubed will always be positive, and 4t to the power of 4 will always be positive. But whether, when I subtract them, I still get a positive, well, obviously that depends on the size of t to the power of 4 compared to the size of 4t cubed. So I don't think I can really draw any conclusions from that. But if I go to the factorised version, then I can say, well, because t is between 0 and 4, t cubed is always greater than or equal to 0, and 4 minus t is also greater than or equal to 0, because t is never greater than 4. So, and then if I think that through, so I'm only ever going to have, well, not necessarily a positive times a positive, because they could equal 0, but neither of those is ever going to be negative. So the product of them is never going to be negative. So, so I just need to think about how I can sort of write that in the shortest way possible while still getting my point across. So, so I think, well, I've already clearly shown that they can't be negative. So I just put neither t cubed or 4 minus t can be negative, therefore their product. Oh, hang on. Oh yeah, no, that's fine, right? So neither t cubed or 4 minus t can be negative, so therefore their product can never be negative. And they did specifically say, so when they said non-negative rather than positive, that wasn't just being awkward. We can't say it's always positive because it could equal 0. So that's why they sort of said non-negative. Okay, and then find the maximum displacement of the body from its starting point. Okay, so in this type of question, whenever they start talking about maximums or minimums, that will be to do with stationary points. So the same that it did in your core maths. So, and if I'm thinking about stationary points, I'm thinking about differentiating. So if I want to differentiate, I want to go back to the expanded version. So if I differentiate that, I get 12t squared minus 4t cubed. Okay, so both the maximum and minimum displacements will be stationary points. So let's find those. So I can take 40 out as a common factor. So I know, in fact, well, that I can take 40 squared out as a common factor. So that's going to leave me with 3 minus t. So I've got t is 0, and t is 3. Well, I can clearly see that if I substitute t as 0 into s, that's going to give me a displacement of 0. So I don't think I need to check the second differential to decide that it's that one that's going to be the maximum displacement. And I know from the previous part of the question that when t was 0, it was at its starting point, obviously its displacement was 0. So when t is 3, s is 4 times 3 cubed minus 3 to the power of 4. So if I stick that into my calculator, I get displacement of 27 meters. Okay, and I don't think I need to justify that that's the maximum because there were only 2 stationary points, and I know, just logically, I know that that's the minimum displacement. Of course, if you have a graphical calculator, you could just plug that graph in, and it just helps clear everything up. Okay, and we're good.